In section 1, we saw what quadratic functions look like when we graph them. They look like what? Parabolas. So then we learned how to graph a parabola. In section 2, we learned how to graph a parabola a little bit easier. In section 3, we started to see where the solutions to a function were. The solutions are the same as the zeros. They're the same as the x-intercepts. They're the same as the roots. And they all mean the same thing, where the graph crosses the x-axis. So in section 3, we graphed to see where the parabola crosses the x-axis. And then we could say the solutions are here and here. In section 4, we're going to use algebra instead of graphing. Algebra is always more powerful than graphing. Graphing is nice to see visually what's going on, but if you can use algebra to solve a problem, you're always going to be better off. So, section 9.4, factoring to solve quadratic equations. You have to remember chapter 8, how to factor, doing a GCF, undoing FOIL, using the box method, factoring by grouping. All of those ideas in chapter 8 come back now in chapter 9 to help us solve equations. Now before we get to factoring, we need to learn this thing called the zero product property. This is a hugely important property. It's kind of a shame that it's been this long in this class before we learned the zero product property, because it's a really important, really powerful, really nice property to know how to use. Solving equations using the zero product property. Before we get to that, let's take a look at this. If we have two things that are being multiplied together to equal 0, what has to be true? Yeah, one of them has to be 0. Because the only way I can multiply two numbers together and get 0 is if something is 0. 0 times anything is 0. So A could be 0, and if A is 0, then I have 0 times whatever that is, and that's going to be 0. Or B could be 0, and then I have A times whatever it is. Sorry, A times 0, whatever A is, times 0 would be also 0. What if both of them are 0? Then you still get 0. But something in there has to be 0 in order for this to be true. And that's what the zero product property actually says. If a product of two factors is 0, then at least one of the factors must be 0. Then down below, for this statement right here to be true, either A equals 0 or B equals 0. They both could be 0, but for sure one of them is 0. That's the only way to multiply two things together to get 0. So if that's true, then here I have something right here times something right here is equal to 0. If I'm going to multiply two things together and that equals 0, then what has to be true? One of them has to be 0. So either this thing right here is 0 or this thing right here is 0. So what we can do is we can write it that way. We can say the 2d plus 6 part has to be 0, or we could say the 3d minus 15 part has to be 0. That's the zero product property. I have two things being multiplied together right here. One or the other has to be 0. So I use the zero product property and I say this has to be 0, 2d plus 6 is equal to 0, or I say 3d minus 15 has to be 0, so 3d minus 15 equals 0. And now I can solve those two equations and find out what d could be to make this a true statement. So I can subtract 6 from both sides here, and that gives me 2d equals negative 6. So I divide both sides by 2, and I get d equals negative 3. That's one solution. If I add 15 to both sides here, then I have 3d equals 15. Divide both sides by 3. And we have d equals 5. That's a second solution. Now check to make sure that you're right. Take the negative 3 and plug it in up here. 2 times negative 3 is what? Negative 6. Negative 6 plus 6 is 0. But if I take that negative 3 over here, 3 times negative 3 is negative 9. And then negative 9 minus 15 is like negative 24. And then I had 0 here times negative 24 here, which is 0. So I wound up with a true statement there. This answer works. If I take the 5 and I plug it in, 2 times 5 is 10 plus 6 is, so we get 16 for this first part, times 3 times 5 is 15. 15 minus 15 is 0. So we have 16 times 0, which is 0. So it makes the statement true. If you use the zero product property, as long as you have a 0 sitting here, and you have things that are being multiplied together, you can split them into 2 separate equations and then solve. That's the zero product property. So let's take a look at these 6 problems. We want to try to use the zero product property to solve these equations. So in that first one, we have 3n times n plus 2 equals 0. Do we have things that are being multiplied together? Yeah, notice that the 3n times the n plus 2 is equal to 0. So if that's the case, then what can we say? Yeah, either this is 0 or this is 0. Because in order for these two things to multiply together to give me 0, either we have to wind up with 0 here or we have to wind up with 0 here. So now 3n equals 0, solve for n. What do we do? Divide by 3, n equals, over here, solve for n. What do we do? Subtract 2 from both sides, and we get n equals negative 2. 2 answers. Check your work. Take 0 and plug it in up here. 3 times 0 is 0. Now I have 0 times something. Doesn't matter what this something is at all. What do I get? 0. Take the negative 2 and plug it in. In the first part I get what? Negative 6. And then here I have negative 2 plus 2, which is 0. So negative 6 times 0 is 0. Both of these answers work. Now what's going on in this second one here? Am I ready to use the zero product property? No? Why not? Really? Everything's being multiplied together right now? No. What are we going to have to do? Factor. The zero product property has things that are being multiplied together. I have something here times something here. I don't have that here. Yes, these are being multiplied together. Yes, these are being multiplied together. But we have subtraction in between. This is strictly times. I have two things being multiplied together. I don't have just that here. So I need to factor. So what should we do? What's the first thing you do, any factoring problem? Greatest common factor. What is the greatest common factor of 8b squared minus 40b? 8b. So I factor out the 8b, and what's left over? b minus 5 equals 0. Now, do I have two things that are being multiplied together? Yes, I do. I have this 8b right here, and I have this b minus 5. I made factors. Factors are things that get multiplied together. Now I can use the zero product property. I have a 0 sitting here, and I have two things being multiplied together now. This thing right here, and this thing right here. So, use the zero product property. What do we write? $8b equals 0, or b minus 5 equals 0. So, what do we do here? Okay, and what do we get? b equals 0, or what do we do here? Add 5 to both sides, and we get b equals 5. Two answers, b equals 0 or b equals 5. check it. Go back to the original problem. If I plug 0 in up here, what does that first term turn into? 0. And then what does that second term turn into? So I have 0 minus 0. 0 times 40 is 0. So I have 0 minus 0, which is hopefully 0. If I plug 5 in, I have what right here? 25 times 8. I got 8 quarters. How much do I have? If I had 8 quarters in my pocket, how much money would I have? I'd have $2. So 25 times 8 is 200. Now 40 times 5, what is that? 200. So I have 200 minus 200, which is 0. So both of these answers work. Now what's going on with this one? How is this one different than these other two? Yeah, we don't have equals 0. On this one we had equals 0. On this one we had equals 0. On this one we don't have equals 0. Can I use the zero product property if I have two things that multiply together that don't give me 0? No, I can't. It is zero product property for a reason. You have to have equals 0. So that means we have to move everything over to the other side first. So what could I do? We're never going to divide. We're just going to move. Plus 10x to both sides. And now I have x squared plus 10x equals 0. So now this problem looks just like this problem. What should we do here? Factor. Factor out a GCF. What do we have for a GCF? X times x plus 10 equals 0. Now what? Use the zero product property. Say it to yourself. Use the zero product property. That way it'll help you remember that that's what you're doing. So what do I write? Or? Okay, well this is nice. This is already solved right here. So nothing more to do there. That's an answer. Over here, what do I have to do? Yep, subtract 10 from both sides, and we get x equals negative 10. There's my second answer. X equals 0, or x equals negative 10. Now to check this, go back to the original problem. Plug 0 in. What's 0 squared? 0. What's negative 10 times 0? 0. 0 equals 0. True? Yes. Take negative 10, plug it in. What's negative 10 squared? Positive 100. Then we have negative 10 times negative 10. What is that? Negative 10 times negative 10 is positive 100. 100 equals 100. True? Yes. So both of these answers work. Okay. These three problems are for you. They're very similar to the three problems above. So if you're not sure what to do, look at the problems we did above and they should help. Go ahead. Tell me what to do. First problem. Yep, it's all set right now. We have two things that are being multiplied together, so what do I write? Good. And what do we do on the first one? Just solving for k, we divide both sides by 3. K equals 0. What do we do on the second one? Subtract 10 from both sides. Again, just solving for k. K equals what? Negative 10. We have two answers here. Done. Second one, what should we do? Factor. Okay, so look at this. How do I factor that? Common denominator. We're not looking at fractions. Greatest common factor. So what is the GCF here? 5p. Open up parentheses. What's left over? 4p minus 3 equals 0. Now what? Zero product property, so I write okay, so on this first one, 5p equals 0. Yep, divide both sides by 5, and p equals 0. And the second one? We need to add 3 to both sides. Remember our rules from solving equations all the way back in chapter 2. We now have 4p equals 3. Save the division for last. Divide both sides by 4, and p equals 3/4. There you go. Those are the correct answers. What do we do on the last one? Okay, we do have two things that are already being multiplied together. This thing right here, and also this thing right here. It's ready to go. So we can do zero product property right now, because that is equals 0. So what do I write? Good. And what do we do on the first one? And that gives me? Good. And then we divide by 4, and we have m equals -1/2. And the second one? Add 9 to both sides, and we have, and then we divide both sides by 3, and m equals 3. That's how you do the zero product property. You have to have a product before you can use it, and it has to be equal 0 before you can use it. But once you get that, then you can solve. Homework problems 8 through 13 all, just like these. Okay, notice the directions here are, again, what is the solutions? What are the solutions? Solve, that sort of thing. And notice that we have equals 0 going on. There is an equation here. So we need to solve. We need x equals or y equals or whatever the variable is equals. If I were to graph this equation right here, what would it look like? What's the word for the graph of that type of equation? Starts with a P. Parabola. Yeah, it's going to look like a parabola. This parabola is going to be what? Opening up. So that means that if this was my graph, my parabola could look like that, which means how many solutions would I have? 2. It could look like this, where the vertex just touches the x-axis, which means how many solutions do I have? 1. It also could look like this, in which case how many solutions would I have? None. Yeah, 0. So these equations right here are parabolas, which means we're going to have 2 solutions, 1 solution, or no solution. We are going to be solving these equations using algebra. The same ideas that we learned in Chapter 8 with factoring come into play here. And then this concept that we just learned, the zero product property, allows us to solve. So, if this thing has a solution, if this thing crosses the x-axis, I'll be able to factor it. I'll be able to solve this thing and get real answers. So let's see if we can factor this. How would I factor it? Look for a GCF. Is there a GCF here? Nope. Then that means that either I'm going to have to use the box method, or I can just break it into a FOIL problem. Is that what I should do, or should I use the box? The number in front of the x squared term is 1, which means I don't need the box. Save yourself the trouble and just do that. Now, straight out of Chapter 8, I'm going to have an x here and an x here. Both signs will be positive. And what two numbers multiply to give me 15 but add to give me 8? 5 and 3. So I put my 5 there and my 3 there, and then what should I do from Chapter 8? Check to make sure that you got it right. So 5 times 3 is 15. 5 plus 3 is 8. So we do have the two numbers correct. Now, look at what this looks like. Two things multiplied together equals 0. What can we do? What's that called? The zero product property. Get that in your mind so that you remember it. People forget it, and then they don't know what to do. So we're going to use the zero product property here with two things that are multiplied together equals 0. X plus 5 equals 0. Or x plus 3 equals 0. Split it up, two separate equations. And now solve. Subtract 5 from both sides. This is easy here. We get x equals negative 5. Subtract 3 from both sides. We get x equals negative 3. Two answers, and we're done. So if we were to graph this, what would we see? Yep, you would see a parabola, and the parabola opens up, and it crosses the x-axis at negative 5 and negative 3, which is right there. So maybe that parabola looks like this. Okay? This is the connection that you need to make between what we're doing here and what we did in the first three sections. This algebra is giving me this without actually making the graph. Later on, maybe we'll take a look at what the graph looks like. But for now, this is the algebra that's giving me these 2 points right here. If I plug negative 5 in, I get 0 for y, which is what that says. If I plug negative 3 in up here, I get 0 for y, which is what that says. So that's what's going on here, okay? Keep that connection in your mind. We are working with parabolas here. So let me get rid of this work and take a look at the second one. What should we do? Okay, GCF. Is there a GCF here? No, so then we're going to factor. Box method or just undo FOIL? Undo FOIL equals 0. Now what? One is positive and one is negative. Good. So now that I know that, which number is going to be the negative number? The bigger number is negative. So two numbers that multiply, there's not many choices here for 14. What does it have to be? Yeah, 7 and 2. So the 7 is negative, the 2 is positive. Now what? Check. Positive 2 times negative 7, negative 14. Positive 2 plus negative 7, negative 5. We got it right? Now what? Zero product property. Product because we're multiplying in between. And zero product property because these two things multiply to give me 0. So it's zero product property. What do we write? Good? Good? And so on this one, subtract 2 from both sides, and we have m equals negative 2. And on this one, add 7 to both sides, and we get m equals 7. Two answers. So this, if we were to graph it, would be a parabola that opens up, and that parabola is going to cross the x-axis at, or the m-axis, I guess in this case, at negative 2 and positive 7. So if you want to picture that in your mind, negative 2 is there, positive 7 is all the way over there, so maybe this parabola does something like that. Okay? It's helpful to picture in your mind what's going on. It is not required, though. Oops, I didn't want to do that. It is not required for this section. It's just nice to know that that's what we're doing. Go ahead and try the third one on your own. What do we have? GCF, not other than 1. So undo FOIL equals 0, P, P. And my signs are plus, minus. And my numbers have to be 5, negative 4. Yes. Check. 5 times negative 4, negative 20. 5 plus negative 4, positive 1. So those are correct. Now what? P plus 5 equals 0. You guys are way too young in this process to be skipping steps. P minus 4 equals 0. So split it up and actually write that down. I know that some of you can probably do this in your head at this point, but I do want you to write it down every time because there are going to be more complicated problems here than these. So subtract 5 from both sides, and we get P equals negative 5. Add 4 to both sides, And we get p equals 4, just like you said. So those are our two answers. This parabola would cross the x-axis where? At -5 and +4. Yep. And it opens which way? Opens up. The y-intercept would be where? Way down there at -20. All right, how about this last one? What should we do here? Before that, look for a GCF. Is there a GCF here besides 1? No, so then we are going to use AC. AC equals what? 36. Now I need two numbers to multiply to give me 36, but add to give me -15. They both have to be negative. This is just like the bell ringer that I gave you guys earlier. -3, -12. -3 times -12 is +36. -3 plus -12 is -15. So those are the correct two numbers. Now what do we do? Set the box. That's what I said. This is the bell ringer. 2a squared, first box, first term. Last box, last term, the 18. And then my two numbers, -3a and -12a. Now what? The GCF for the rows and columns. Top row is 2a. Bottom row is -3. And the first column is a. And that's a negative sign. I don't know what happened there. And the last column is -6. So then normally my answer would be 2a minus 3 times a minus 6. But remember, this is an equation. It's equals 0. So we have to equal 0, which means we got to continue. So what happens next? Yep, now you can use the zero product property. So 2a minus 3 equals 0, or a minus 6 equals 0. So what should we do on this left one here? Right, we're going to add 3 to both sides, and we get 2a equals 3. Now what? Divide both sides by 2, and we have a equals, I don't see a negative sign, but it is 3/2. Leave it like a fraction. 3/2, perfectly fine. 1.5 is right, but 3/2 is fine. And the second one, we have a minus 6 equals 0. So we're going to add 6 to both sides, and we have a equals 6 for our second answer. So if we were to graph this, we would see a parabola that opens up, has a y-intercept at 18, and crosses the x-axis at 3/2 and 6. On your homework, you might also see something like this. We've kind of seen something like this before. What do we need to do here? We can't do the zero product property here if this isn't a 0. So we have to, we got to get everything on one side equals 0 on the other side. So now I have 4x squared minus 21x minus 18, and now I have equals 0. So now I can factor and use the zero product property. All right, GCF here, is there a GCF? No, unfortunately, these are going to be big numbers. So that means we go with AC, and what is 4 times -18? Yeah, it's -72. All right, we're looking for two numbers that multiply to give us -72, and at the same time add to give us -21. So let's think about the signs to try to help us along. What do the signs have to be? Yeah, one has to be positive, one has to be negative. And the negative one is the bigger one, yeah. So let's start thinking of numbers. Think of something, just give me something. 1 and 72, is that going to work? No. 2 and 36, is that going to work? No. Does 3 go into 18? Does 3 go into 72? Yes, because 7 plus 2 is 9, and 3 goes into 9. So 3 does go into 72. How many times? 24? 3. Does 3 go into 72? Yes, 24 times. And we said that the bigger one had to be negative and the smaller one had to be positive. If that's the case, do we have our two numbers? Yeah. So just start with 1 and then go to 2 and then 3 and then just work your way through until you find one. So we said it was positive 3 and negative 24. 3 times negative 24 is negative 72. 3 plus negative 24 is negative 21. So those are the correct numbers. Now what? Box. We have 4x squared. We have negative 18. We have 3x. We have negative 24x. GCF, first row. Yes, it is 4x. And the bottom row? 3, good. And the first column is just x. And the last column? It's negative 6. The first box is negative, so it has to be negative. 6 times 3 is 18. 6 times 4 is 24. Okay, now what? Yep, write out the stuff. So we have the 4x plus 3 times x minus 6 equals 0. Now what do we do? Now the zero product property. 4x plus 3 equals 0. Or x minus 6 equals 0. Good. We are going to not add 3 though. We're going to subtract 3 from both sides. 4x equals negative 3. And then we divide both sides by 4. And x equals, don't lose your negative sign after all that work, that'd be terrible, negative 3/4. Second one? Yeah, that's an easy one. Add 6 to both sides, we get x equals 6. 2 answers, and both of them work. This parabola crosses the x-axis at negative 3/4 and positive 6 if we were to graph it. Also, it opens up, and it would be fatter or skinnier than usual. With this number right here, it's bigger than 1. It's going to be a little skinnier than usual. Okay, that really, we have 2 problems left, but that is everything that is done in this section, so you are capable of doing the entire homework assignment at this point.